And this is going to be the second part to the pressure switch video that I was trying to put together. So it's going to deal strictly with a two-stage scroll gas pack unit that we have in the shop. So just to look at it and understand the thought process of the pressure switches and how they're used in the system. I do have a part in here where I throw up the wiring diagram and I point to the pressure switch, the first one and the second one. And also throw a picture in for the two-stage scroll compressor if you've never seen one. So a little look at the plugs and the labeling that they have on those. And I also go in and you can skip through it with the chapters or whatnot, but I go in and try to take apart the plug and clean up some wiring. So it is what it is. Hopefully you'll get something out of it. Yeah, and that's it. I did trim my beard, but unfortunately since the week or so that I did the video, it's kind of grown back, so don't hate on me too bad. I know it's a little bushy looking, so we'll get out in the shop. I need to trim my beard, but whatever. Hey, I'm gonna show you this. This is a package unit that I've been on before. There it goes. I did a video or two on this one, but this is something pretty neat. If you look right up in here, I can see two pressure switches, right? There's two pressure switches right there, side by side. So those two pressure switches, they are both in the discharge line of this unit. And I also have another one right here in the liquid line, all right? So this is, it caused me to question why I have two pressure switches. So on the diagram here for this particular package unit, well, I hope it works. So I can find my contactor coil. This is pretty typical. I've got my contactor coil here, and you can see that my low pressure switch is listed as being in series with the Y circuit, and my high pressure switch, but it says high pressure switch 1. All right, so for my main circuit board here, I have a Y terminal. This is a power output, so power is going to come out of this. It's going to go over and down and goes into the high pressure switch, then the low pressure switch, contactor coil, and then it, back to common, and the low voltage circuit is completed. So it took me a second to find the high pressure switch. Now this is a gas pack, so there's some other circuits over here for the furnace part of this, but I found the high pressure switch here, and it goes to a compressor solenoid, which this scroll compressor is a two-stage scroll compressor, and the high pressure switch evidently is regulating for the second stage, which is fairly neat. I've never seen that before. So I don't know how this video is going to come up. I'll try to throw up the diagram and circle these just in case. But I sent an email to the pressure switch manufacturer, and I started doing the video because I got tired of waiting on the information, and they just sent it back. And basically what they told me was they can't sell me the part because that part is specific to a Carrier brand unit. And I told them, like, that's good. I don't want to buy it. There's nothing wrong with mine. I need the details on it. So I guess I'm gonna wait and see what the details are. But what I'm gonna do is I'm gonna show you how I would figure this out using my meter and my gauges and what I know about the cycle and how this thing works. And we can just kind of break this pressure switch down. So I'm going to turn it around and I'll show you how it connects up. So over here on the side of my unit is my low voltage, I'll call it. It's a DC powered solenoid, but it's not high voltage power. The high voltage power is over here on this side, so it kind of looks like it's got two ears on it. And this one is going to be for the staging of this scroll compressor. So you can kind of hear it. It's pumping hard. My high side pressure, I got 254 over 102, R410A. If I unplug this, the compressor quietens down. That solenoid is no longer powered. What I'm gonna do here is I'm gonna stick my 2 electrical leads in here. And if you read on the side, it says I'm gonna have a 24 volt DC output. Input's gonna be 24 volts AC DC, but the output in here is gonna be DC. So I'm gonna put my leads in here and I'm gonna set that there. And I'm gonna come over here and I'm gonna use my meter. I'm gonna set it to DC, which is not typical unless we're doing some controls, you know, but for residential it's not real typical yet. So right here I've got right at 22 volts DC. And how I'm gonna do this is I am going to pull the fan, because in a package unit the L1 power comes off the common terminal. So I'm gonna pull this and the start winding for that fan. So I'm gonna pull everything for the fan off the capacitor, and that's gonna kill my condenser fan. And I'm gonna see at what pressure my pressure switches open for both the high pressure switch 2, which controls the staging, and high pressure switch 1, which is general safety for the contactor coil circuit. So here we go. There's the start winding, and there goes the run winding for the fan. So my condenser fan, I'm not doing anything to it. Contactor still engaged, and we're gonna watch the pressures now. So I'm gonna watch my voltage on here. When my voltage goes to 0, I know that I've lost power, and the reason I've lost power is there's one safety in the circuit, and that is my high pressure switch 2. So both of those pressure switches are watching the discharge temperature, and I can only assume that if there's not enough refrigerant or something goes wrong, we don't want to stage that compressor up and increase the pressure anymore. Not real sure. The engineers are playing email tag with me. So 325 on the pressure. I've still got voltage. I did it a little bit ago and I wrote down some numbers. It looks like at 560, maybe 550, depending on the actual details on my meter and my gauges, but somewhere around 550 I should lose my DC voltage here. So I'm gonna pick that up and watch it. Should take me just a minute. I can feel the heat coming off the condenser. So it shouldn't be but just a second, and you should see, like I said, if you're out in the field doing this, you gotta use your sense. So as soon as we lose this 22 volts DC, that'll be roughly the pressure, and it ought to trip here in just a second. There it goes. I heard it click. Our DC voltage went down, and we were somewhere around 560, 565. So I'm gonna let that go and continue on. And what I'm gonna do is I'm gonna drop down here because this is a hot mess. So if you really wanna know what all is going on with it, sometimes you gotta cut some zip ties. So I'm gonna cut this zip tie, and I'm gonna make sure I know what pressure that the real high pressure switch is gonna trip out at. So if I follow that solenoid wire back, what I'm gonna find is somewhere right here. But these two wires are coming from
a plug, and it looks like this one right here. So this is my solenoid. Man, somebody really messed this up. What I'm gonna do is, once I see where this thing trips out, I'm gonna fix all this. If you've never seen one of these, this is a little pin tool. Whoever's been working in here has thoroughly tangled all this up, so we can't get to it right. So what I'm gonna do is I'm only gonna pull one of these out. That way I know which one has to go back in, if I got the right size. There we go. So I'm gonna put this pin tool in here, and it's gonna close the barbs up and let me pull that barrel out. And now what I can do is I can take these wires and neatly untangle them so that it's not all clustered together. Man, I hate when people do this. There we go. And since I only undid one of them, I can put it back in the right spot. All right. So this goes to straight to the plug, and that means that the other side of this plug, which is in here somewhere, that means that this guy right here should be my pressure switch. According to the diagram, it's red and red. So if I were to take my two leads and pull them out of the voltage here, we'll do continuity. I got continuity. I can do continuity on these two, and it is still open. All right, so what I'm gonna wind up doing, I've got the power off right now. Oh, thunderstorm. Got the power off right now. I'm gonna try to untangle some of these wires. Who did all this? Somebody tried to wrap all this stuff up. So I got my plug. Down here, I've got pressure switches, we got the fan. Boy, this is a cluster. Right. So I'm gonna make this as neat as I can and get back. All right, so I kind of cleaned it up. I'm gonna try something with this particular set up. I've got to where I hate zip ties, so I'm gonna try putting in some Velcro to see how long that lasts, versus just cutting up plastic and keep throwing it away. So hopefully this Velcro stuff will catch on a little bit, especially here at in my line of work, but or my part of the field, I should say. So I'm gonna, when I bundle these back, I've separated the safeties for the furnace, I've separated the blower. This is an ECM motor, so it's got a bunch of wires going to it. I've got some crankcase heater wires. I've got the high pressure switch 2. That's the actual pressure switch right there. I've got my run and start winding for my condenser fan. I've got the Molex plug that actually takes the voltage to the solenoid plug-in for the compressor. So I've kind of got everything separated. I'll try to pretty it up when I get everything back together. And I forgot to plug that wire in. I had crimped that wire a little better because that brings power to our common terminal for the compressor and the fan. So as I said, everything's pretty much back. I'm gonna let it warm back up. I think I know exactly when it opens and closes, but we'll watch it one more time. This time we'll do it a little bit different. I'll go ahead and just do it by continuity. Since I have 2 pressure switches, I know that this one is only for the staging of the unit to second stage. So I will hang that ever so gently right here. And wait for this thing to trip out. All right, so our unit just came back on, and I've got the continuity going for the pressure switch. So it's right here at the top. I got 350. I've got the condenser fan unplugged, so we're gonna hit our pressure pretty quick. But if you don't have an idea of when this thing opens and closes, a real simple test is do continuity on it. It's going to be aggravating for just a minute, but you can actually use your meter to figure out roughly what the set points are for the opening and closing. So right now it's a normally closed switch. We're going to see at what pressure it opens, and then as the unit cycles off, what pressure it closes at. All right, so we're getting in the mid 500s. Last time it should open about your 560 mark. So we're 555 now. Still got continuity. 560. 565 and some change. And I heard it click, and I just went OL on my my meter here, so I know the switch opened. I can leave that in there. I'm gonna double check myself and make sure that I know when this unit actually cuts off. And once it cycles off on the true high pressure switch that's in line with the contactor over here, then as the pressure drops, I'm gonna plug in the fan, put it back on the dual capacitor. I'll plug in the, or I will watch to see what the continuity does with the pressure as it falls. And we'll establish the opening and closing point for that pressure switch. All right, so she just tripped out. So about 650 on the pressure switch. I'm gonna go ahead, now that was for the main what the diagram says, HPS1. So I'm going to go ahead and plug the condenser fan back in. I'm going to plug that wire in. There we go. And we'll listen for the continuity beep for it to come back. All right, so what I got, I'm watching the pressure come down, and I got my meter set to continuity on the pressure switch. So I thought I had it somewhere around the 450 mark as I watched it the last time. So there goes the normal high pressure switch, and there goes, so it's about 430. I don't know if you saw that. The regular high pressure switch that also is in series with the low pressure switch and the contactor, it closed, and that brought the contactor coil on. And once a little bit of airflow was established, then my meter started doing a tone for continuity at about the 430 psi mark. So I know now that that high pressure switch 2, which controls the staging, or is the safety for the staging, it opens at about 560 and closes at about 430, and that's its kind of range for its operation. So I'm gonna go ahead and close this back up, put some Velcro everywhere. So this, according to the diagram, is going to come out. That's my pressure switch. The plug on the compressor is already in, so if I go ahead and plug this in, it's probably going to engage that second stage, and we can watch that pressure happen right here. So first stage, if you watch your low pressure and your high pressure, when it stages up, you'll hear it. The amp draw will increase on the compressor, and it'll be moving more refrigerant. There it goes. See the high pressure going up, which I've got the blower door off here, but the high pressure goes up and the low pressure dips down a little bit because it's pumping more in second stage. So that's just a little bit on pressure switches, how you can use voltage and continuity to troubleshoot them, how you can use the system to help you establish some range, some set points for it if you can't get the manufacturer's data, but simple devices.